This is another video regarding acids bases. In this video, we will be talking about what is an acid, what is base, and what is the behavior of an acid and what is the behavior of a base. Yes, these terms are not limited to the chemistry subject, not limited to the chemistry lab. These are also present in our everyday life also. Let's see, have a look at these terms one by one. First one, that is acid. All the citrus fruits like lemon, grapes, they taste sour to the tongue. Yes, we all human beings, we have characters like male, female, etc. Likewise, in acids also, there are some types depending upon the food that we take. Suppose if we take tomato juice, it has an oxalic acid and its formula is C2H2O4. And if we take tamarind, and it contains tartaric acid, right? Its formula is C4H6O6. And coming to vinegar, if we take vinegar, it has acetic acid and its formula is CH3COOH. Likewise, depending upon the food that we take, acids may vary, but they all come under the acids. Acids can usually be identified as sour taste by the tongue. There are certain things that exhibit property which almost chemically opposite to the acids are said to be the bases. Yes, three scientists, namely Arrhenius, Bronsted-Lowry, and Lewis, come forward to distinguish an acid and base. According to their, let's see one by one. According to the Arrhenius theory, let's see what is an acid, what is a base. Yes, according to the Arrhenius, a substance which gives H plus ions when dissolved in water is said to be acid. According to the Arrhenius, yes, a substance which gives OH minus ions when dissolved in water is said to be the base. According to the Arrhenius, that is regarding the Arrhenius theory simply. And coming to the next one, Bronsted-Lowry theory. Yes, according to him, acid is said to be all the proton donors which gives H plus ions. Those substances which gives H plus ions to the others are said to be the acids. All the proton acceptors that it takes H plus ions from the others are said to be the bases according to the Bronsted-Lowry. Yes, coming to the third one, that is Lewis theory. And according to the Lewis theory, an acid is said to be the electron pair acceptors. All the electron pair acceptors are said to be acids. And all the electron pair donors are said to be the bases. Yes, here is an example that exemplifies what is acid, what is base. With this we can see. And here is ammonia, NH3, and boron trifluoride. Yes, in ammonia has a tendency to give lone pair of electrons to the boron so that it becomes base. Here is boron trifluoride. It has a tendency that accepts the electron pair from the ammonia so that it is acid. Yes, it gives the lone pair of electrons to the boron so that it is, and it has an accepting tendency from the ammonia so that it becomes an acid according to the Lewis theory. Yes. Next, coming to the identification of acids and bases. How we can identify that a particular substance is an acid, that a particular substance is a base, means we have three methods. The first one, that is by the litmus paper. Second one, that is pH meter and certain titrations. Upon the uses of indicators in titrations, acid base titrations also, we can distinguish that a particular substance is an acid and that a particular substance is a base. Let's see one by one. The first one, that is by the litmus paper. Yes, we have a litmus paper. If a particular solution is dipped in the litmus paper, upon dipping the litmus paper into a particular solution, if the color of that litmus paper turns from blue to red, is said to be the acid. And upon the dipping of litmus paper into a particular solution, if the color changes from red to blue, it is said to be the bases. That is regarding the litmus paper, right? I am coming again regarding this litmus paper identification. If a particular solution, upon dipping a litmus paper into a particular solution, if the color of that litmus paper changes from blue to red, is said to be the acid. And if a litmus paper is dipped in a particular solution, if the color of that solution changes from red to blue, is said to be simply bases. Yes, coming to the next one, that is pH meter. Yes, pH meter is introduced in 1909, but we are studying in 20th century also. Yes, that much of important has this pH meter. Yes. To know the strength of an acids and bases, this pH meter is very much useful, and this pH meter has the reading from 0 to 14. Yes. If a particular solution gives the reading below 7 is said to be acid. If a particular solution has the reading above 8 to 14 is said to be the basis. If a solution has the reading that is from 6 to 7, in between 6 to 7, it is said to be the more acidic solution. If a particular solution gives the reading in between 13 to 14 is said to be the more basic solution. If a particular solution gives the reading 7, they are said to be the neutral ones, neutral solutions. Yes, in mathematical terms, how we can calculate this pH in the sense, in logarithmic terms, that it becomes 1 into 10 to the power of 0 for the 0 reading. If it gives the pH meter reading as 1, that that we can calculate as 1 into 10 to the power of minus 1. Likewise for the 2, 1 into 10 to the power of minus 2. Likewise for the 3, 1 into 10 to the power of minus 3. If it gives the reading as 14, it becomes 1 into 10 to the power of minus 14. Right. That's how we can calculate this pH. There are the third one, that is indicators in titrations. We have certain indicators that are used regularly in acid base titrations, namely phenolphthalein indicator, methyl orange indicator, methyl red indicator, and methyl blue indicator. Yes, if 2 to 3 drops of phenolphthalein solution is added to titration, if the indicator turns the color of the solution to colorless, are said to be acid. If 2 to 3 drops of methyl orange is added to a solution, if the indicator changes turns red color to the red color, are said to be acid. If the indicator turns the solution color to the yellow, is said to be the base, if upon the usage of methyl orange. Next, coming to the pH. Yes, what is the pH in the sense, what's its use in the sense, in your human body has certain range of pHs, like our eyes contains certain range of pH, our stomach and tongues, intestines, likewise in every part of our human body has certain range of pH that is useful in our daily life. For example, our stomach has an acidic pH. How we can calculate in the term, in the means, pH is the negative logarithm of H plus ions. Yes, its definition is, it's the negative logarithm of hydrogen ion concentration, and mathematically it can be represented as pH equal to minus logarithm of H plus ions concentration. If the stomach has a pH of minus log of 10 to the power of minus 6, upon the usage of antacids, the pH concentration is reduced to minus 4. This is the usage of pH in our daily life. So, pH is the negative logarithm of hydrogen ion concentration. That is regarding acids, bases, and its behavior and identification, and pH also. Subscribe my channel, don't forget about this, and if you have any queries in chemistry subject, you can comment me and ask me. I'll give you notes regarding a particular substance that you want. Okay, subscribe my channel.